In exercise 2.8, we will look at line plots. So we use the filtered version of the dataset we generated in exercise 2.7. And then we generate line plots in the following way. So we use the group column on the x-axis and the column look to intensity on the y-axis, and then draw lines between data points that belong to the same person, which is defined in the column patient number. So here we read in the long format dataset, and in the exercise before we have filtered it by this specific protein here. So we recreate that. And then here for the line plot, we use geom line, and in addition, for example, also geom point to have also data points and lines. And we use the group on the x-axis, log 2 intensity on the y-axis, and patient number as the group to create a line plot. And you see here that you have here the data points, and the lines always combine data points that belong to the same patient. We see that there's a tendency that this protein is higher in the control group and is downregulated for most of the patients in the cancer tissue. There are some exceptions. For example, for this patient here, the value goes up. For this patient here, it roughly stays the same, but for most it goes down. In exercise 2.9, we are doing bar plots, which show the total sum of intensities in each sample. So we use the long format dataset, calculate the total sum of protein intensities for each sample by using the summarize function, and then we create bar plots that show this intensity actually. In an advanced part, we will have a look at how to make the plot a bit nicer. So we have the problem here that the samples on the x-axis are sorted in an alphabetical order, which is quite weird because then C2 is right after C19, because this would be the alphabetical order. And then we will see how we can sort them actually by the sample number. Okay, so first we load the dataset, and then we use the group by function on the name column, which is the column containing the sample names, and summarize them by calculating the sum of the intensities, call it total sum, and keep in mind to remove the missing values before calculating the sum. And then we receive a smaller data set, which here contains only the name of the sample and the total sum of intensities. But we want to do the plot by group, and then we can here use the separate wider the lim function to extract the information on the group and the sample from the name column, which is delimited by an underscore. And then we can use this with the geom bar, which does the bar plot with the identity as the statistics. And then we use x as the name, y as the total sum, and fill as group. And you can see here that we have for each sample of the controls and the HCC group, we have the total sum of intensities plotted. And this is actually varying between each sample. And here we see the problem with the ordering. So C1 is followed by C10, and then C19 is followed by C2, and so on. So the ordering is alphabetically and not really in order of the sample ID. Yeah, this is what we can do here. I will just use factor on the name, which is at the moment a character. The sample should be a numeric, so this is basically 2 transformations at the beginning. And then we will use the forcats package and the factor reorder to reorder it first by the sample and then additionally by the group. And if you look now at the result, you will see that here in the levels, you will have C1, C2, C3, and so on in the correct order, and not alphabetically, but in the order of the samples. First the controls and then the HCC. So we have first ordered it by the sample, which would have resulted in something like C1, then HCC1, C2, then HCC2. But then we reorder it by group again, so that it gets again separated by the group. And if we now use this data in the plot, you can see that this ordering is also now done in the plot here. In exercise 2.10, we are again doing bar plots. So basically the same as we did in 2.9, but we add error bars. So we calculate now the mean and standard deviation of the total intensity sum with each group. And then we use that to create bar plots with error bars. So I will read in the data again from before, from the exercise before. Okay. So here we have the total sum data frame, which contains the total sum of protein intensities for each sample. And now we actually aggregate that and calculate the standard deviation and the average of this total sum by group. So we use the group by and the mutate function for this. Have a new data frame. And this now contains here, as you can see, the standard deviation and the average for each group. We can now use that to have a bar plot with X as the group here, Y as the average, and fill as the group for the coloring. And then we have geom bar, but we have also geom error bar, where we can have the y min and y max based on the average plus and minus the standard deviation. And then we can see here a direct comparison between the two groups and see that the total sum of intensities is on average a bit higher in the HEC group, but also the variance is higher in this group. For exercise 2.11, which is the last one in this session here, we do a heat map of the significant proteins. So we use the long data format here. I will just start reading it in. And we filter it for p-values that are below 10 to the minus 8. So very low p-values. And then we generate a heat map that shows the log transformed intensities of these significant proteins over the different samples. So here we filter the data for the p-value below 10 to the power of minus 8. You see that it gets much smaller, so we only have 266 observations. And then we use the geom tile. And on the x-axis we use the name, so different sample names. On the y-axis we use the gene name in this case. And we fill it with the log2 intensity. So this is the color that is used in the heat map. And if we do this, you can see here the names of the samples, the gene names that are highly significant. And you can see that the log2 intensity is coded by color. So high intensities are light blue, low intensities are dark blue. And of course, you can use the same trick in principle as before with the bar plots. You could also reorder the names here, but we skipped it here.